Welcome to Rogni College of Engineering. I am Reggie, Associate Professor, Department of ECE. Today in this session we are going to discuss about link budget and link margin. So from link budget and link margin, students can understand what is a link budget and what is a link margin. What is a link budget? Link budget is an accounting of all power gain and loss in the communication system. That is all the power gain and power loss experience in a telecommunication system from a transmitter through a media and to a receiver. It is an equation giving the received power from the transmitter power after the attenuation of transmitted signal due to propagation as well as antenna gain and feed line and other losses and amplification of the signal in the receiver or any repeaters. A link budget is a design aid calculated from the design of communication system to determine the received power to ensure that the information is received intelligibly with an accurate signal to noise ratio. Randomly variable channel gains such as fading are taken into account by adding some margin depend upon the anticipated severity of the effect. The amount of margin required can be reduced by use of mitigating techniques such as antenna diversity or frequency hopping. Randomly varying channel gains such as fading are taken into account by adding some margin depend upon the anticipated severity of the effect. The amount of margin required can be reduced by mitigating technique such as antenna diversity or frequency hopping. A simple link budget equation: received power is equal to transmitted power plus gain minus loss. Note that the decibel are logarithmic measurements so that adding decibel is equivalent to multiplying actual numeric value. Link budget transmitting antenna are the most common, neither isotropic an imaginary class of antenna with uniform radiation in three-dimensional nor omnidirectional class of antenna with uniform radiation. The use of omnidirectional antenna is rare in communication system, so almost every link budget equation must consider. Transmitting antenna typically concentrates signal power in the favored direction normally, that is receiving antenna is placed. Transmitted power is effectively increased in the direction of highest antenna gain. This systematic gain is expressed including the antenna gain in the link budget. The receiving antenna is also typically a directional and when properly oriented collect more power than the isotropic antenna. As the consequences, the receiving antenna gain add to the received power. The antenna gain are scaled by the wavelength, the radiation, the question. This step may not be required in adequate systematic budget. Link budget calculation are messy and complex, so standard practice has been evolved to simplify fixed transmission equation into the link budget. It includes to transmit and receive antenna gain, free space loss, additional loss using line of sight between the transmitted power. Losses factor: transmitting and receiving antenna may be partially cross-polarized. Cabling between radio and antenna may introduce significant loss. Fresnel loss due to partially absorbed line of sight. Doppler shift introduce signal loss in the receiver. The link budget equation include all effect, that is PRS is equal to PTX GTX minus LTX minus LFS minus 1. PRS is the received power, PTS is the transmitted power, GTS is the antenna transmitter gain. Link budget equation: LTS is the transmitter loss, LFS path loss, LM miscellaneous loss or polarization, GRS receiver antenna gain, receiver losses. Link budget: the loss due to this propagation between the transmitting and receiving antenna are often called as path loss and written as LFS in dB is equal to 20 log to the base 10 4 pi distance by wavelength. Where the substituted in the link budget, the result is the logarithmic form of fixed transmission equation. So LFS equal to 32.45 dB plus 20 into log frequency plus 20 into log distance plus LFS dB equal to 27.55 dB plus 20 into log distance frequency plus LFS dB 36.6 dB plus 20 into log frequency plus 20 into log distance. The alternative form can be derived by substituting the wavelength with the propagation velocity 3 into 10 power 8 divided by frequency and by inserting proper conversion ratio between kilometer and meter into hertz. So from this, link margin and link budget can be calculated with respect to the values, and the marginal value can be given in terms depend upon the loss. Thank you.